math analyzers, and welcome to your Chapter 7 Lesson 2 notes. We are going to graph exponential functions today, which is review from Algebra 1. So I'm going to fly through this part, okay? So you're just going to have to kind of get ready to go and start writing. All right. An exponential function is one in which the x is in the exponent. Okay, so your variable, the thing that changes with each of your x points, is the exponent itself, which means that base is being raised to a whole bunch of powers, and your y is the result of doing that. Basic exponential functions are either increase or decrease, growth or decay. Growth being increase, decrease being decay. So as we can see, here's an exponential decay function. And again, decay, decrease, right? And here's an exponential growth function or increase. I want you to look at their bases. If the base is a fraction lower than 1, so between 0 and 1, then you're going to get a decrease or a decay. If your base is a number greater than 1, so even like 1.5 as a base, any number greater than 1, that's going to be a growth model for exponentials. Okay, so what we do is we look at this general form of graphing an exponential function. A is going to be our y-intercept. B is going to be the base. X obviously is the exponent, the variable exponent. And C, that's going to be our asymptote, what we're adding or subtracting off the end. Okay, so that's going to help us determine where we go. Now, I'm just going to quickly graph these most basic exponential functions right here so you can see how their tables match up. I can already tell you that here is a growth function because my base is 2. Okay, so let's look at from -4 all the way to +4. This is just the most basic doubling and halving functions that we have. So if I am taking my 2 as my base and raising it to the first power, then my result is 2. 2 raised to the second power, well, that's 4. 2 raised to the third power, well, that's 8. 2 raised to the fourth power, that's 16. So you can see you've taken your number and you've doubled it each time. So if I need to go backwards and go into the negatives as far as my x goes, as far as my exponent goes, I'll be halving. 2 to the 0 power is 1. There's my y-intercept. 0 in my number, y-intercept. 2 to the -1 power is 1/2, because what's half of 1? 1/2. What's half of 1/2? 1/4. What's half of 1/4? 1/8. What's half of 1/8? 1/16. And I don't know how I'll very well be able to represent 1/16 on my y, but I'll give it a go. So, of course, graphing the integer points is just so much easier. So I'll kind of start there as far as graphing goes. 2 to the 2, 4, and then 3, 8, and then 4, 16. Now let's head back the other direction. So let me connect what I have and notice I am at a rapid increase, real rapid increase. Well, let's go back here and let's zoom way, way, way in. Okay, zoom way, way, way in. And look, -1 as your x has a 1/2 as the y. So go halfway up. -2 as your x has a 1/4, so halfway between 1/2 and 0. And then -3 has a 1/8, halfway between 0 and 1/4. And then 1/16 is halfway between 1/8 and 0. And as you can see, when we go back this direction, we are approaching a y value of 0, but we're never going to actually make it there. And that is the asymptote that we are approaching but can never touch or cross. And that, in this case, happens to be y equals 0. That's going to be our asymptote. The asymptote, of course, is that thing that really defines in our heads when we're looking at an exponential function, right? That is the thing that makes it look exponential because it's that like kind of even out spot, even out. But there's a lot going on. It's just the problem is when you keep taking half getting towards zero like that, it's harder and harder and harder and harder to show that, right? Because your numbers get so small that your graph would have to be so huge to be able to fit that, but then you wouldn't have this side of it either. So that's what's the trouble with exponentials is it's really hard to comprehend both directions, both how big, how fast, and how small these pieces are. It gets difficult to comprehend. Okay, I understand that. I do. Let's go for the decay model over here. And let's do this in red so I can do them right next to each other. And I'm still going to do my same x values and look at their matching y's. So I'm taking 1/2 to the power, right? So 1/2 to the 0 power is still 1, right? But 1/2 raised to the first power, well, that's itself. So that's 1/2. And 1/2 squared, that's 1 times 1 on top and 2 times 2 on the bottom. So that's 1/4. And 1/2 cubed, well, that's still 1 on the top, but on the bottom, it's 2 times 2 times 2. That's 8. I'm actually getting smaller and smaller on this end, on the positive exponent end, just because of having half as my base, having a fraction as my base as I'm doing this. So when I have the negative end, I'm actually flipping that fraction upside down and raising it to power. So 1/2 raised to the -1, that's 2. 1/2 raised to the -2 is 4. Raised to the -3 is 8. And raised to the -4 is 16. And look at that. Look at that comparison. Okay, it's really just the opposite of what we just did as far as graphing goes. -3, excuse me. Just want to make sure I get that in the right spot. Okay, now taking half, right? So it's halfway between, and then halfway between, and then halfway between, and then halfway between, and it gets too close to even try to do too much there. And then, of course, when you do your arrow here, keep it straight. Don't point it down because this is still your asymptote. And an asymptote for an exponential is always going to be y equals, right? And what is it? It's the value that your y will never technically be. Okay, it's the value that your y is trying to get to but will never technically be. Okay? And so that's our real basic exponential growth and decay functions. Those are the most basic that they get as far as your bases go and what fits on the graph best in a lot of places. So each exponential function of this form has a y-intercept of, well, 0, 1, and an asymptote of c, or 0 in this case. So hold on, let me change that because I'm looking at the form. There we go. Sorry. Yeah, that's right. I'm saying that right. That's a line though. This is a point. So let me do 0a. So I was closer the first time, right? There we go. That looks better. This y-intercept is a point, excuse me. And this is a line. So that's why it needs to be y equals. All right. So if your base of the exponent is greater than 1, we've already talked about that. That's growth. And if your base of your exponential function is between 0 and 1, so it's a fraction less than 1, that's going to be decay. Notice we're not talking about negatives there, and we're not talking about 0 there. So avoid that base being a negative number there and avoid that base being a 0. We're not going to deal with that currently. Not going to deal with that currently. Okay. So now let's just take a peek at what changes occur here. So notice my base is 2, right? I'm raising to the 2. I'm raising 2 to these different powers. When I'm doing that here, now after I get my y, I also multiply it by this front number. And that's why the y-intercept changes to be that. Okay. The other thing that'll happen, this is positive. So this is all, they're all just going to increase 5 like that. But this, since it's negative, it's actually going to flip over the x-axis. So really kind of let's do this. Let's take the table from y equals 2 to the x power. And then let's expand it to have this one and this one. Okay. So we had -4 all the way up to and including +4. Now what we're going to do is just reiterate what we had on the other side. So I'm just copying. Okay. Now, what I'm going to do first is do the multiply by 5 one. Okay. So this is going to be, we'll call this y2. And we'll call this guy over here y3. All right. Because this guy, he was my y1 over from the start. Okay. So what I'll do here for y2 is now I also multiply this number by 5. So this is going to be 5/16. And this is going to be 5/8. And this is going to be 5 halves. Fourths, excuse me. This is going to be 5 halves. That's where the 5 halves is. And 1 times 5 is 5. And 2 times 5 is 10. And 4 times 5 is 20. 5 times 8 is 40. And 5 times 16 is 80. Whoa. So obviously I have less potential points to fit on this graph, but on this end, think about it, my asymptote is still 0, but it's going to take me a little longer on that end to get close to it, right? So let's kind of do the integer points first. So 0, 5, and then 1 all the way up to 10, and then 2 all the way up to 20. That's the best I got on that end because I'm not going to fit 340 on here. Okay. But on the opposite end, 5 halves, well, that's 2.5, right? So 1 up to 2.5. And then 5 fourths, well, that's 1 in 1.25, right? So 1 in 25 hundredths. So right here. And then 5/8, well, that's here, but not quite to half. And then, oh, now we're getting a little less than half. And so see, now it's actually going to take us longer to approach that asymptote from that end because of our front number. But notice that y-intercept change. Okay, notice that y-intercept change. The asymptote is still 0. And yes, we always label an asymptote. You just say A is y equals 0. When it comes to an exponential, that is part of the graph, so it does have to be labeled on it. We still need to take the original for this one. So let me just reiterate the original one, which was and 1/16 and 1/8 and 1/4, 1/2, 1, 2, 4, 8, 16. And now let's get our y3 up here. You purple people, you win all the time. Now we're going to multiply by -3. So this is -3/16. This is -3/8. This is -3/4. This is -3/2. This is -3. This is -6. This is negative, multiplying by -3, -12. This is -24. And this is -48. So notice we're on the other side of the x-axis this time. Those are negative y's. So this flipped, the fact that this was negative flipped my whole function over the x-axis. And that makes sense because when your a value is negative in a parabola, it's frowny face. When your a value is negative in an absolute value, it's an A shape instead of a V shape. That makes total sense. So I'll graph the two integer points that I can, 0, -3, and 1, -6, because that's it. That's all I'm going to fit on this end. And then let's graph these guys. So -1, -3/2 is right here. And -2, -3/4 is right about there. And -3, -3/8 is right about there. And so, of course, right about here. And we're approaching our asymptote of 0 still. Because again, we still haven't had a number added or subtracted off the end. So this still has an asymptote that does need to be labeled, because that's part of the graph, and of course, label the function. Oh, look at this purple smearing all over the place. Trash color. Okay, so just look at that comparison. And now algebraically, if I just kind of prove that to you, and I'm just going to do this quick, because then we'll just look at a few graphs. If I algebraically put a 0 in here, because the y-intercept has an x value of 0, if I algebraically put a 0 in, 2 to the 0 power is 1, and 5 times 1 is 5. That's how I know that's my y-intercept. Two to the 0 power is 1. -3 times 1 is -3. So that's how I know this is 0, -3, and 0, 5 for my y-intercepts. Okay? Having that a value in front changes things, changes your y-intercept. All right. Well, the last thing we have here is just when adding or subtracting in the exponent, you move left and right. This is transformations, all stuff we did in Algebra 1, okay? But now, instead of actually graphing it out, because that'll take us a bit of time here, we now just have kind of samples already graphed showing you that that's happening, okay? So just some samples of adding, subtracting, when you add or subtract off the end, and this is where that asymptote comes into play. We graphed this one and we knew the asymptote was y equals 0, right? But now if I move everything up 3, well, now so does my asymptote move up 3. If I move everything down 3, so does my asymptote move down 3. So that's why the number added or subtracted at the end is giving you the value of your asymptote. Okay, it's giving you the equation that your asymptote is going to be. All right. And then, of course, flipping over the x-axis, it has a negative a value. And if you make your exponent negative, that's a reflection this way. Okay, so that is very similar to changing your base. Oh, negative exponent making a fractional base. Oh my God, they come together. There we are. So those are the different transformations you may run into. Those are the different things you may see happening to your equation. You thankfully have a graphing calculator where you can plug those equations in, get those values. You'll see these changes. Okay, so you don't have to worry about this nearly as much, but know that this is what is happening in those equations that makes this occur. Okay, that's what's happening in these equations. Even though we talked about that in Algebra 1, I know that it's a lot of exponential review to take in between these two lessons because we do have to dig back and start to move forward. Okay, and when we start to really move forward in Algebra 2 with this, it's with the next lesson where now we're going to start looking at equations where x is in the exponent, and we have to be able to solve those. Okay, that's a real Algebra 2 level concept, and that's where we're getting. So, guys, practice these graphs that I give you for homework tonight and just looking at the equation in the graph and identifying the y-intercept and the asymptote. There's a sketch where you just look at the equation and do those, which is fine. You'll be able to do that. Use the notes to help you, okay? I'll see you very soon. Bye. Enjoy your exponential functions.